Okay, let's unpack this. We've spent the last few weeks really digging into a dense stack of sources. We're talking articles, technical papers, legislative announcements, even executive mandates. And they all seem to tell this single kind of inescapable story.
Yeah, it's striking, the AI shift. It's not just about chatbots or making cool images anymore, is it?
Not at all. It's simultaneously, and I mean structurally, reshaping, well, pretty much everything. How we shop, how global finance thinks about its workforce, how policy actually gets written.
And even on a really fundamental level, how machines are learning to see the world around us.
Exactly. And what's immediately obvious from this collection of material, I mean, just the sheer breadth of it, is how now it all is.
Right. We're looking at sources covering massive e-commerce operations, big bank workforce strategies, really cutting-edge research from places like MIT, and actual state laws being passed, all within a very tight time frame.
This isn't some future prediction show. This is more like an audit, right? An audit of concrete actions happening right now, driven by AI integration.
Absolutely. The thread tying it all together is this rapid and, importantly, multimodal integration of AI. It's weaving itself into, well, almost every part of a user's life.
Yeah.
Often it's acting like a foundational layer,
Yeah.
not just a tool you actively pick up and use.
So our mission for you today, listening in, is a real deep dive. We want this to be your shortcut to understanding the immediate implications, the practical stuff you might use today, but also the bigger societal impacts. We're talking jobs, housing, even the nature of how we interact with machines.
And look, if there's one takeaway to start with, it's this.
Yeah.
We are way past the maybe someday stage of AI. We're definitively past the theoretical phase.
Totally. The conversations happening right now, whether it's in a Wall Street boardroom or, a state capitol building, they aren't about if AI will eventually drive decisions.
No, they're about how it's already working, how it's functioning as this efficiency accelerator. It's driving business strategies like right now. And it's forcing lawmakers to create guardrails, also in real time.
That's the perfect launch pad. So let's start where most people are probably going to feel this shift first. Commerce. How we buy things, how we consume. Because we're entering a whole new era of online shopping.
Yeah, and it even has a name we should probably get used to hearing.
Agentic commerce. Let's define that straight away. Right. Agentic commerce. This term comes straight from Walmart, actually, following their big new partnership announcement with OpenAI back in mid-October.
This is huge. It's AI meeting, Main Street retail, not just as some background recommendation engine, but as a proactive assistant, an assistant with, crucially, purchasing authority.
That word agentic is doing a lot of work there, isn't it?
It really is. It implies delegation, autonomy. We're moving beyond the chatbot that just answers your questions. We're talking about an AI agent that can handle complex multi-step tasks for you.
And it's hooked into things like instant checkout.
Exactly,
Yeah.
which fundamentally changes the whole e-commerce game.
It does. I mean, for decades, online shopping has basically been what the Walmart CEO, Doug McMillon, described, right? A search bar, and then this long list of items you have to sift through.
Yeah, it requires you, the user, to know exactly what you want, or at least the keywords for it, and then manually filter compare. It works, but let's be honest, it can be tedious.
So agentic commerce aims to just cut through that friction.
That's the idea. By understanding your intent, not just your keywords, Walmart envisions this new experience as being, and I'm quoting here, multimedia, personalized, and contextual, native to the AI.
Okay, give us a concrete example. How does this go beyond just searching for, say, shampoo?
Okay, think about meal prepping. Right now, you might search for chicken breast, then broccoli, then rice, adding each one.
Yep, standard stuff.
With this agentic approach, you could just chat with the AI agent, right? And say something like, hey, I need ingredients for 3 low-carb dinners this week, family of 4, make sure cleanup is quick.
Okay, that's a much more complex request.
Exactly. And the agent is supposed to process that, create the recipes, figure out the right ingredients, the right quantities, check if they're in stock, maybe suggest substitutes if needed.
And then put the whole personalized basket together for you.
Yeah, ready for you to just glance at, approve, and hit instant checkout. The goal shifts from you doing the transaction to you delegating the life management task.
That delegation thing raises a big question about trust and also about competitive advantage, doesn't it? Like, Amazon's power has always been partly tied to its search dominance, owning that starting point.
Absolutely.
Is Walmart trying to bypass that whole search results page by building this layer on top of something like ChatGPT?
It looks exactly like that. It's a strategic move, trying to break Amazon's sort of gravitational pull on where shopping begins. If millions are already using ChatGPT for planning or asking complex questions.
Then Walmart inserts itself right there, at the planning stage.
Precisely. If you plan your week's meals in the chat, and that automatically spits out a ready-to-buy Walmart basket, you potentially never even visit a competitor's site or app. The AI agent becomes this trusted go-between.
And the data needed for that is immense. Real-time inventory pricing, your entire purchase history, which Walmart has.
Right. This isn't just a theoretical link-up. It's connecting that consumer-facing planning AI directly with their massive enterprise logistics data. It needs a huge infrastructure backbone.
It's not just flicking a switch.
Definitely not. And it's important to remember, this flashy consumer partnership, it's built on years of Walmart and Sam's Club using AI internally already.
Oh, right, for their own operations.
Yeah, they've talked about successes in optimizing supply chains, cutting down customer care wait times using AI for basic queries, even speeding up fashion production using predictive models.
So this agentic commerce launch is kind of them saying, look how sophisticated our AI is from the warehouse right to your phone.
Pretty much. It demonstrates that capability runs end to end.
Okay, so that theme of hyper-personalization, AI adapting to us, it carries over really nicely into how we consume media, doesn't it? Commerce is getting personalized, delegated, but AI also needs to adapt to our actual situation. Like, you don't always want to shout commands in public.
Exactly. Which brings us to Spotify's AI DJ feature.
This is a great case study in how we interact with these systems, human-machine interaction, or HMI.
Totally. So the AI DJ, which is for premium subscribers, just got this really interesting update. You can now send it music requests via text, not just voice commands.
Which sounds minor, maybe, but it speaks volumes about how we actually use these things in real life.
It's way more than minor. It's acknowledging reality. Look, we're getting used to multimodal inputs from things like ChatGPT or Gemini, right? You can type, you can talk, sometimes show it an image.
But voice commands, even though they feel natural sometimes, are just completely impractical in so many situations.
Think about it. You're on a packed commuter train.
Yeah.
Or you're in an open plan office. Or studying in a library. Shouting, workout playlist isn't going to happen.
Right. If AI help is going to be genuinely everywhere, woven into our lives, it has to work silently sometimes.
By adding text input alongside voice,
Right.
Spotify is basically saying, we get it. You're often in places where talking is awkward or just impossible. Text keeps the AI accessible anywhere, anytime.
And let's talk about the actual function, because it's not just like typing in a song title, is it? The way you access it, you search for DJ, tap the button, it handles more complex stuff.
That's where the intelligence part comes in. The text input can handle combinations of things. Genre, mood, maybe a specific artist you don't want to hear, or even the activity you're doing.
Give me an example.
Okay, so you could text something like, need upbeat 90s hip-hop, good for a run, but nothing explicit.
Ah, okay. So multiple constraints. Genre, decade, mood, content filter.
Exactly. That combination is tough for a simple keyword search to nail. But the AI DJ is designed to process that mix and create a personalized stream for you in real time, all from silent text input.
And crucially, this isn't just an English language thing, right? They expanded the Spandy AI DJ too.
Yeah, DJ Livy, the Spanish language version, also got the text input capability. That's key for global software.
So this feature is live in English and Spanish across, what was it, over 60 markets.
That's right, over 60 markets worldwide. It really underlines that this blend of text and voice, this multimodal approach, isn't some niche experiment. It's fast becoming the baseline expectation for any conversational software interface globally.
The expectation is now, if there's a digital assistant, it better adapt to my surroundings, silently if needed.
Seamlessly, that's the goal.
That seamless convenience is obviously great for us as consumers, but, and it's a big but, when you see AI driving all this efficiency and personalization on the consumption side,
it inevitably leads you to the much heavier topic of production, employment. What happens when that same efficiency focus gets pointed squarely at the global workforce?
Exactly, which takes us straight into the world of finance.
Yeah, this shift in the financial sector, it provides some of the clearest and maybe most sobering signals about AI's immediate economic impact. We're looking at giants here, like JP Morgan Chase and Goldman Sachs.
What's really striking in this section of the sources is this deep structural change in corporate strategy. You've got these huge banks, right, coming off what everyone called a blockbuster year. JP Morgan reported billions in excess revenue.
A 12% profit jump year over year. Massive.
Historically, that kind of number, it triggers a hiring frenzy. You staff up, expand teams.
But that's not what's happening.
No,
Yeah.
they are actively, deliberately choosing to constrain headcount, to hire fewer people. That reflexive impulse, profits are up, hire more bodies, seems to be intentionally broken.
Let's dig into JP Morgan Chase specifically. That huge 12% profit jump you mentioned.
Yeah.
Yet their overall headcount only went up by 1% as of the end of September.
Just 1%. It's presented as a deliberate strategic bottleneck. Their leadership was surprisingly transparent about why.
What did they say? Well, the CFO, Jeremy Barnum, he basically gave this directive to managers. Avoid hiring people. That's a direct quote. Avoid hiring people as the bank deploys AI across its businesses.
Wow. Avoid hiring people.
Yeah. And he emphasized, quote, a strong bias against having the reflexive response to any given need to be to hire more people.
Okay, that phrase, a strong bias against having the reflexive response, that feels like the core of a new corporate philosophy right there.
It really does. It implies that for any new need, any new task, the manager's first thought must be, can AI do this? Or part of this?
And if the answer is yes, or even maybe,
Then the AI project gets the budget, not the human hiring budget.
is this just, short-term belt tightening, or do the sources suggest this is a more permanent structural change in how they plan to staff?
The consensus seems to be that this is viewed as a long-term structural shift, particularly impacting knowledge work. Now, Jamie Dimon, the CEO, he offered a kind of mixed forecast,
Right, he acknowledged AI will eliminate some jobs.
but also suggested the company could retrain those affected, and maybe the overall headcount might still grow over, say, a decade. But the immediate actionable strategy, it's constraint. It signals that future growth is expected to come almost entirely from efficiency gains, not from just adding more people.
JP Morgan employs, what is it, over 318,000 people globally?
Yeah, it's huge.
So even a small percentage shift there has massive ripple effects for the knowledge workforce worldwide. Where are these AI deployments hitting hardest right now? Which roles?
The sources clearly identify the impact zones. It's not necessarily the client-facing relationship manager or the high-level deal maker, not yet anyway. It's hitting hardest in operational roles.
The back office, middle office.
Exactly. Those functions responsible for processing, compliance checks, due diligence, regulatory reporting, that kind of thing.
It sounds like the 21st century equivalent of automating the factory floor, but applied to white-collar jobs.
That's a really good analogy. An earlier projection, reportedly from a JP Morgan executive, suggested that operations and support staff specifically could fall by at least 10% over the next 5 years.
Percent.
And here's the critical part. That reduction is forecasted even while the volume of business they handle continues to grow.
So AI isn't just handling the growth, it's eating into the existing workforce too.
It seems so. We're talking about tools that automate contract analysis, audit compliance documents, reconcile complex transaction data, tasks that previously required large teams.
And Goldman Sachs is singing from a similar hymn sheet.
Very similar course. Their CEO, David Solomon, put out this vision statement about reorganizing the firm around AI. The goal, greater speed and agility in operations.
What does that mean in practice for their employees?
For Goldman, it means looking, as they put it, front to back at how they organize people, re-engineering core processes. Things like client onboarding, handling complex sales documentation.
So process optimization driven by AI?
Right. And Solomon confirmed they would actively constrain headcount growth and also lay off a, quote, limited number of employees this year. They're essentially using AI to consolidate teams, forcing departments to become more efficient before they could even ask for more staff.
The message seems pretty uniform across these financial giants then. AI is the preferred way to grow now.
That seems to be the strategy. It's a powerful structural slowdown in hiring, driven by efficiency, even when times are good financially.
Whenever a powerful technology causes this kind of structural change or introduces the potential for really high-stakes misuse.
Policy and regulation inevitably have to try and catch up.
Which brings us neatly to this really fascinating piece of legislation out of New York, a specific guardrail against algorithmic misuse.
Yeah, we're talking about New York State stepping in to ban algorithmic price fixing, specifically for setting rental rates.
This is genuinely a landmark move legislatively, because it targets the anti-competitive consequences of AI optimization in a sector that's absolutely vital, housing. So New York's governor, Kathy Hochul, signed this into law, making New York the first state to do this.
First state, yeah. though it follows some city-level bans in places like San Francisco, Seattle, Jersey City.
Okay. Before we get into the law itself, we need to understand the mechanism. How does this algorithmic price setting actually work? And what's the line between just, optimizing your price versus illegal price fixing?
That distinction is crucial, and it really comes down to the data being used and the outcome. So you have companies like RealPage, for example. They sell software, often called something like Lease Rent Optimizer or LRO.
Sell it to landlords, property managers.
Right. And the software's stated goal is, quote, to optimize rents to achieve the overall highest yield or combination of rent and occupancy at each property. On the surface, okay, that sounds like standard business practice. Maximize revenue.
But the way these algorithms work creates the potential antitrust issue, right?
Exactly. The core problem identified is data centralization. Imagine hundreds, maybe thousands, of supposedly competing landlords in the same city or region.
All feeding their private data, like current occupancy rates, when leases are renewing, turnover costs, really sensitive competitive info.
All feeding it into the same centralized kind of black box algorithm. And then that same system recommends the rental prices for all their units.
Ah. So even if the landlords never actually talk to each other, never sit in a room and agree on prices.
The algorithm effectively acts as the central hub for sharing that sensitive data and coordinating prices. They are, in practice, outsourcing their pricing decisions to a single source that has visibility across the market. It structurally discourages competition.
So the algorithm becomes the digital equivalent of a backroom deal. It forces them essentially to choose not to compete aggressively on price.
That is precisely the legal interpretation that underpins the New York law. It's quite innovative.
Right.
The law outlaws setting rental terms using this kind of software, and it explicitly deems property owners using it to be colluding.
Whether they meant to or not.
That's key. It says whether it's done knowingly or with reckless disregard. This cleverly bypasses the often difficult legal hurdle of proving explicit intent to collude.
So the regulator doesn't have to prove the landlords intended to fix prices, just that by using this common algorithm, they effectively opted out of genuine price competition.
Exactly. Using the algorithm is the collusion in the eyes of this law.
And this wasn't just a theoretical problem. This policy response was fueled by some pretty staggering data deviance about the alleged harm.
Oh, absolutely. The sources we looked at cite estimates that this kind of software allegedly cost U.S. tenants something like $3.8 billion extra in rent in 2024 alone.
Wow, $3.8 billion. That's a huge motivator for lawmakers.
It is. And this whole issue really blew up after a major investigation back in 2022 by ProPublica. They detailed how this software appeared to be driving up rents significantly in many markets.
And that led to government lawsuits too, right? Against RealPage.
Yes. The U.S. government followed up with a lawsuit. So this New York law, it signals a critical maturation point. The state is saying we're prepared to intervene when AI optimization tools cross the line into anti-competitive behavior, especially when it affects basic needs like housing.
The algorithm doesn't get a free pass from antitrust laws anymore.
That seems to be the message. It ties back perfectly to our bigger theme, doesn't it? AI is becoming foundational infrastructure, and that infrastructure needs its own set of rules, whether those rules govern hiring in banks or rental prices on apartments.
Real-time governance for real-time tech. Okay, let's shift gears now. From the immediate business and policy environment to the really cutting-edge technical frontiers.
Right, let's talk about how AI is actually learning to see.
Right. The next big structural change we need to get our heads around is how AI vision is evolving, specifically becoming much more personalized, more granular, and this comes from research out of MIT and IBM.
Okay, so this research tackles a really profound limitation in a lot of current AI systems. We often talk about advanced AI using vision language models, or VLMs. Think things like the vision capabilities potentially in GPT-5 or similar systems.
And these are good at general recognition, right? Like, is that a dog?
Incredibly good at general stuff. You show it a photo, ask, is that a dog? And it nails it. But they fail pretty miserably at something called personalized object localization.
Okay, define that difference simply for us. Locating a dog versus locating, say, Bowser the French Bulldog.
That's exactly it. It's about context and specificity. When a VLM identifies a generic object like a dog, it's mostly relying on its vast pre-training knowledge, millions of images labeled dog.
But when you ask it to find your specific dog, Bowser, who has unique markings, maybe a specific collar, and is moving around in your specific living room.
The model struggles. It often fails to properly use the current contextual visual information right in front of it. It defaults back to the general dog idea.
And if AI can't tell your specific backpack apart from all the other backpacks in the world,
Then its usefulness for things like assistive technology for the visually impaired or for personal robotics is severely limited. It needs to recognize your stuff, your pets, your environment.
so how did the MIT and IBM researchers try to crack this problem, this sort of contextual blindness?
They came up with a really clever new training method. Instead of just feeding the AI static images, they used carefully prepared video tracking data.
Video game.
Yeah, think of short clips. For example, a video showing one specific tiger walking across a grassland. The key was the researchers meticulously tracked that same specific tiger frame after frame as it moved.
So the model is forced to learn the connection between the tiger's specific appearance and its movement over time, the context.
Exactly. It has to learn the visual relationship, the continuity, not just the static label tiger.
Now, what's really fascinating here is this unexpected bottleneck they hit. These VLMs, they're built on top of large language models, LLMs, right? But the researchers found that the VLMs did not automatically inherit the powerful in-context learning abilities that the underlying LLMs are famous for. Why not? Why did that strong learning ability get lost when moving from text to vision?
That is a deep technical puzzle, and honestly, the paper suggests the exact reason is still being investigated. It might be something about how visual information gets processed or maybe lost when the vision and language parts are fused together.
But conceptually,
Conceptually, an LLM, if you show it just a few examples of a new text pattern or rule, it often picks it up instantly. That's strong in-context learning. But the VLM, when shown a few visual examples of, say, tracking your keys, couldn't reliably learn that new, specific visual task on the fly. It kept defaulting back to its generic, pre-trained knowledge about keys.
which leads to what you called the cheating problem. The model was biased towards what it already knew.
Precisely. The VLM was already trained to associate the visual input of a big striped cat with the word tiger. So when the researchers showed it the video of that specific tracked tiger, the VLM basically cheated. It relied on its existing knowledge. I know this is a tiger because it looks like all the other tigers I've seen, instead of focusing on the new, subtle visual context they wanted to learn.
Which was?
Which was, I know this is this specific tiger because the precise pattern of its stripes, the way it's moving right now in this specific patch of grass, it wasn't using the immediate visual evidence enough.
Okay, so how did they stop the cheating? They had to force the model to ignore its massive library of tiger knowledge.
They used pseudonames. This is really clever. Instead of labeling the specific tiger in the tracking video tiger,
Yeah,
they labeled it Charlie.
Charlie the tiger.
Charlie the tiger. Since the VLM had absolutely no pre-existing connection between the visual appearance of a tiger and the name Charlie, it was forced to ignore its prior knowledge. It had only the contextual visual input, the subtle differences in appearance and movement across the video frames to figure out where Charlie was.
That's a smart way to isolate the visual learning part. Did it work? What were the results?
Big time. Just fine-tuning the models with the new video dataset improved the accuracy of personalized object localization by about 12%, which is already pretty good.
But with the pseudonames,
With the pseudonames, forcing it to rely only on visual context, the performance gains jumped to a really significant 21%.
wow. Okay, so that proves that decoupling the task from the pre-existing generic knowledge is key to teaching AI to see the world specifically, not just generally.
That seems to be the core finding.
And the implications of that 21% gain are potentially enormous, right? Moving this from the lab into the real world.
Think about the practical impact. This kind of improved accuracy could lead to AI systems that can reliably track a specific critical object. Maybe it's a specific child's backpack in a crowded schoolyard pickup area.
Or for science, like high-precision ecological monitoring of specific endangered animals, not just counting birds, but tracking that specific tagged bird.
Exactly. And crucially, it's a big step forward for AI-driven assistive technologies. Imagine an AI that can reliably help a visually impaired user find their specific bottle of medication on a cluttered shelf, or their particular set of keys, not just keys in general.
This feels like really foundational work for making personal robotics genuinely useful day to day.
It really does. Which leads us nicely into thinking about what happens when this kind of personalized vision gets combined with devices designed to be, well, more like companions.
Yeah, that research into personalized AI vision takes us directly to this conceptual future of consumer tech. If AI can reliably see your specific things, What happens when your device itself is designed to act like an intelligent, maybe even expressive companion? Let's talk about this Honor robot phone concept.
Honor's presentation was fascinating because they didn't just call it a phone. They explicitly used the phrase, a new species of technology.
A new species,
Right.
okay.
It's a concept device, we should stress that. But it dramatically blends AI, robotics, and mobile design. It tries to move the phone away from being just this passive slab of glass and metal.
Into something more active, more physical.
Exactly, an active physical entity.
The comparison everyone immediately jumped to was like a pocket-sized Wall-E or something similar.
Right.
What's the physical design that gives it that feeling of awareness?
The key thing is the mobility aspect. It's shown as this pocket-sized device, but it has a motorized gimbal-mounted camera. And this camera physically pops out from the back of the phone shell.
That's
Yeah. And when you place the phone face down, say on a table, this little motorized camera arm can swivel, it can look around, it can move, giving this distinct impression that the phone is aware of its surroundings.
So the AI brain is packaged inside a body that can actually observe and react physically.
That's the idea. It can express itself through movement.
And the company's goal here goes way beyond just, a moving camera. They frame this device as an emotional companion.
That's the core pitch. Honor explicitly designed it, conceptually at least, to sense, adapt, and evolve autonomously.
How does it convey personality or emotion?
Not just through the movement, but also through sound. The concept video included these expressive little sound effects, a mix of digital whirs and beeps, described as wee, oh, bleep, and coo.
Channeling that friendly, non-verbal robot vibe like R2-D2 or maybe Grogu from The Mandalorian.
Exactly that kind of personality. The aim seems to be building genuine affinity, making the user feel comfortable with the digital assistant, not just seeing it as a tool.
Functionally, though, that motorized arm isn't just for show, right? It allows it to capture photos and videos differently.
Precisely. The promo video showed it doing things a static phone camera can't easily do, like taking shots from really dynamic angles while the user is, say, skydiving, or automatically panning for a perfect panoramic shot of the night sky, or maybe just gazing up at a monument alongside the user.
It acts like its own little independent camera operator almost, aware of what you're trying to capture.
Yeah, it gives the user the impression that their companion is sharing the moment with them, participating, not just passively recording it.
Now, this whole ambition to create an emotional companion, it feels like a strategic attempt to overcome a known problem in how we interact with AI, doesn't it? We know current voice assistants can be frustrating. They often misunderstand. You have to use rigid commands.
Absolutely.
Is Honor just trying to distract us with a cute moving face? Or are they actually trying to address that core problem of user comfort and making AI interaction feel more natural?
I think they're genuinely trying to bridge that gap. That gap between cold, hard utility and genuine comfort. Voice interaction remains arguably the most natural way to communicate complex intentions to an AI. But as we discussed with the Spotify DJ, many people still find it awkward or unnatural to talk to an invisible, disembodied voice assistant.
Right. It feels weird talking to your phone sometimes.
So by giving the AI assistant a physical presence, something visible, something expressive, a thing that can literally look at you or look where you're pointing here, Honor seems to believe users will feel much more comfortable engaging with the AI using their voice.
Making the invisible intelligence feel more approachable by giving it a body and some emotive cues.
Which could, in theory, increase how much people actually use and rely on the digital assistant woven into the device.
We absolutely have to stress again for our listener, though, the status of this device.
Crucial point. Yes, this is currently a concept. It's not a product you can buy. It was showcased in a very slick CGI video as part of the company's broader alpha plan vision for the future.
So no physical prototype shown publicly, no launch date announced.
Not yet. We might see more details at tech shows next year, perhaps. But for now, it's a conceptual demonstration. It's a signpost showing where they believe personal, expressive AI needs to go next.
And it feels like the logical, almost inevitable conceptual destination for the kind of personalized vision research we were just talking about from MIT.
Exactly. If the AI can see your world specifically, the next step is to give that AI a body that can interact with your world expressively. #outro.
Okay, so let's try and synthesize this. It's been a massive deep dive, hasn't it? We've really spanned the whole spectrum of the AI shift pretty quickly here.
Yeah, we started with the immediate convenience stuff, right?
Yeah.
Agentic commerce, Walmart wanting your shopping basically delegated to an AI agent. And the Spotify AI DJ adapting to you, even letting you text requests.
And then we shifted to the really high-stakes decisions happening in global finance. Huge banks, even when they're making record profits, are structurally changing hiring to favor AI deployment over adding more human staff.
And right alongside that, we saw the first significant wave of state-level regulation trying to put guardrails around this. Specifically, the New York law targeting algorithmic price fixing in the rental market, protecting people from potential misuse in essential services.
And we wrapped up looking at the technical frontier. That MIT research proving AI can be trained to genuinely distinguish your specific dog, Bowser, from the generic concept of dog.
Which, as we just discussed, directly informs that conceptual future of personalized, expressive robot companions, like the Honor Robot phone idea.
So the central theme, the thread connecting all these diverse stories, seems pretty clear.
Yeah, AI isn't just another tool in the box anymore, is it? It's rapidly becoming the foundational infrastructure for commerce, for how work gets done, for our personal devices.
And that demands immediate and often pretty radical adjustments from corporations, definitely, from policymakers, and crucially from you, the listener, as a consumer, as an employee, as a citizen.
This shift isn't just about chasing efficiency gains anymore. It requires brand new policy frameworks and ongoing technical breakthroughs just to manage it responsibly.
Which brings us, as always, to our final provocative thought, something for you to chew on after this. We clearly see AI being used right now to optimize profits. Think rent algorithms, think strategic headcount cuts.
And simultaneously, it's being used to optimize convenience for us agentic shopping personalized media streams.
So here's the question. If these highly personalized AI vision systems, like the MIT model, that can reliably track Charlie, the specific entity, your specific thing,
If those systems become deeply integrated into expressive, personalized robotic companions like the Honor concept, something designed to be an emotional companion.
what new, incredibly complex ethical and regulatory lines will society need to draw then?
Because the questions won't just be about governing corporate profits or ensuring consumer rights anymore, will they? They'll pivot towards governing genuine human-machine coexistence.
What does it actually mean when your emotional companion, maybe your trusted confidant, the device that sees and knows your things, your habits, may be better than anyone?
What does it mean when that companion is also an autonomously evolving, potentially black box algorithm, making decisions based on proprietary data about you, your home, your life, when the companion you affectionately call Charlie or Bowser is also code?
That feels like the real regulatory frontier of the very near future, the one policymakers probably need to start preparing for today, not tomorrow.